Hello, guys. Good morning to all.
Good morning, sir.
Very good
Morning,
morning. Very
sir.
good morning, guys. Very good morning. Very good morning. Good morning to all. Very good morning, Ira. Good morning, David. Miracle. Good morning. How are you all? Doing good? Doing
Yeah,
good?
sir.
Okay, that's good. That's good. So, we were doing some questions. No, we were doing not some questions. We were doing the chapter of science. And we did this thing. Okay. Now we will learn about distribution of electrical energy for household purposes. Okay. We will read this. So yesterday we learned about AC and DC. Today we will learn about the distribution, how the distribution occurs. Okay. So who will read this? Miraculin, can you read this? Miraculin?
Yeah, sir.
Yeah.
You may have seen huge electricity poles, transformers, wires, etc. around your houses. The production of electricity is done far away from cities at electricity generation centers. These power plants depend upon water, thermal energy, wind, or geothermal power. Here, electricity is produced usually in at 11 kV voltage, 50 frequency. The system by which electricity is transmitted is from such centers to consumer can be divided into two parts. That is
Okay.
transmissions.
So basically 11 kV means 11,000.
Kilovolt. Kilovolt.
11,000 volt. Okay. And so that much voltage are there. So in our houses, only 240 volt come. Okay. But 11,000 volt, they increase the voltage so that they can transfer it from one city to the another city. Did you understand? Yes or
Yeah.
no? Now, the distribution is divided into two parts. First is transmission system, and the second one is distribution system. Okay. So we'll read this. Yes.
Yeah. By using a step-up transformer, voltage is converted transmissions of electricity at the production center. At the electricity generation center, by using step-up transformer, voltage is converted from 11 kilowatt to 132 kilowatt. Then the electricity reaches at low power station through high tension wire. At low power station, it again converted up to 3.3 kilowatt by using a step down transformer. In this way, by using step down transformer, electricity reaches at home at the village of 220 volt and 50 hertz in its unit of
Okay.
frequency.
Sir,
So
sir, sir.
basically, first is, yeah.
Sir, it's not village, it's voltage.
No, no. At home, at the village
The
of
voltage.
220 volt.
The voltage. 220 volt is the
Oh,
voltage.
yeah, at the voltage. So no problem in that. So what was I'm trying to say? That first the transmission is done. So from the generation where the electricity is generating, from there they are transmitting to the another city by increasing the voltage at by the step up transformer. So that the step up transformer, what step up transformer will do, it will increase the voltage and it can go to travel to the longer distance. That is the step up transformer, and then step down transformer which decreases it, and so that the electricity can go to the home. This is the way of step down transformer. Okay, next part. In this way, yes, Miracle, in this way.
No, I mean, sir, can you please explain
Yes.
the step down transformer again?
So step up transformer increase the voltage, step down transformer decrease the voltage. So, like yesterday, I show you the picture. When in that is step down transformer. That is step down transformer. It is reducing the voltage because our voltage, our house, if it will get more than 240 volt, then many appliances will burn. So to have a safety check, they do the step down transformer so that they can send it like every house with the perfect voltage. Okay. Yeah. Yes. Miracle hertz is the unit of.
Frequency. The number of cycles completed by AC in 1 second is called as its frequency. A frequency of 50 Hz means AC completes 50 cycles per second. That means AC flows in one direction 50 times, while in the other again 50 times in electrical wires, bulbs, and other electrical appliances. This means that a bulb lights up 100 times and goes out 100 times in a second. But due to the lack of perception of such small intervals of time, a bulb appears to glow constantly.
Yeah. So this I discussed. Now we will read this thing again. So you guys can check that. First, it is step up transformer, which is just increasing it the voltage. Big high tension wire having a high voltage, it is going. Then step down transformer, and that we are getting this.
And sir,
Did you understand? Yeah,
I have a doubt.
please.
So why are there two step down transformers? Why are there two?
See, step up transformer is very high. So first, the electricity will go to the electricity office. Okay, there they are reducing it, and then because they have to cover a big area, na? So for that big area also, when they are releasing the electricity from the electricity office, that is also too high. Okay, that is also too high. So for that, they are placing again step down transformer in near the colony, near the houses. Yesterday I
Okay,
show
so
you, na?
basically the first step down transformer will convert 132 kilovolt to 11 kilovolt.
Not 11. 11 kilowatt. No. It is less than 11 kilowatt. I don't know the fixed number, but it is less, but more than the 240 volt.
But
Okay.
the second one, the
The
second
second one,
will convert.
the second one, lastly, it convert into 240 volt, which is usable for our houses.
3.3 kilovolt. Okay, first will transform
Yeah.
132 kilovolt to 3.3 kilovolt. Then second one will transfer 3.3 kilovolt to 240 volt.
Yeah.
240
So
volt
if you are
or 240 volt or 220 volt.
220 to 240, the range is 220 to 240.
Yeah, but
Wait, sir.
Okay.
250, but if
Yeah.
it's 250 volt, the appliance will burn. It is 250.
Yeah.
Yeah.
Yes, Agatha.
So first electricity will come to the electricity generation center at 11
No,
kV.
electricity is formed at electricity generation center.
Okay, and then it
Electricity
will
is
go,
formed. Yeah.
and then after being formed, it will go up to the step-up transformer in which the volt increase or decrease. It will increase, right?
Step up transformer increase.
And then to go through the electricity poles, and then come down the step-down transformer, which will decrease the voltage and then send it to our homes.
Yes. Yes.
Yeah.
Correct. Okay. Ira, what did you understand?
So I understood.
Understood. Just on what happened, Veda? No problem. David, you got it? David, you got it? Is he there? Hello, David. You are mute if you're saying
Yes, sir.
something. Yeah, you understood?
Yeah.
Okay. Now read this.
If the voltage of a transformer is increased, then the current flow reduces in the same proportion. Thus, by using step-up transformers, we change electricity electricity to higher voltage and reduce the current flow. By transmitting this low current, we reduce the losses occurred during transmission. The distribution system is the arrangement which provides power from the substation to the consumer. It involves the feeder, so what is that? Distributors,
Distribute.
distributor, sub-distributors, and servicemen. Normally, there are two types of distribution systems: tree system and ring system. These days, mostly ring system is used. The arrangement of various components of the ring system made by distribution is shown in figure 17.7.
Sir.
So, yeah.
Okay. So basically, in the first line, it's saying if the voltage is increased, then current reduces. How come? That means that even in the test, you said that when voltage increases, current also increases. How come your voltage increases and current decreases?
I'll tell you. I have that answer.
V is equals to IR. Or P is equals to VI.
Higher voltage reduces the current flow.
V is equals to IR or P is equals to VI?
No, the answer is here only. Okay. So, now in this case, basically, we know that power is equals to V into I.
Yeah, voltage into current.
Now, if I will write it like this, P by I is equals to V.
So when you
So
teach that
I
power
is
is equal to voltage into current.
no, that is in the previous chapter, not in this chapter.
Okay.
Okay. So when you will increase the voltage, then current will decreases in this case because power, we are relating it to the power. So to have less powers, here basically what happened, power of a device, like how much power they are consuming is the voltage into the current which they are using. Okay. Voltage into the current they are using. If I will increase the voltage, so because power is equals to V square by R, so if I will increase the power, the resistance will increase and the current will decrease.
No, sir. But use V is equal to IR and then V by R is equal to I and then V is directly proportional to I. But here, how is V inversely proportional to I?
Because here we are using the power formula. The power formula is P is equals to voltage into current. So because of voltage into current is there, so if I will increase the, I will tell you one thing. We'll take one example. Now, for example, there is 20 watts power, okay, and 5 voltage is there, 5 V is there. So what is the current? What is the current flow?
4 ampere.
4 amperes, correct?
Yes.
Now the power is same. The power is same, 20 watts, and I increases the voltage by 10 V. So what will be the current then?
2 ampere.
2 ampere. No, I am putting the power value same and I'm increasing the voltage. In that case, what will decrease? Current will decrease.
Now do same thing for V is equal to IR. V is equal to.
See, V is equals to IR.
Yes.
Okay. Now what is voltage? See, this is the different formula. This is different formula.
Okay.
the power is basically the appliances. Like, because see, we have to reduces the power usage. If I will increase the voltage and if the power decreases, who is this? नाम नहीं लिखा. Priyanka. Okay. Okay.
And sir,
Okay. Yeah.
but in the test, no, you said that if H is equal to I square RT and voltage is doubled, then can we use H is equal to V into I into T?
Now in that case, P is equals to V square by R.
But
Okay. P
I
is
want
equals to V.
H. That question was
I know. H is equals to I square RT is there. So if I will increase the current, the heat will increase. That is correct.
yeah. But there are things when voltage is doubled, what is the
So now in this case, if voltage is double, for example, if I will do P is equals to 2V square by R. Okay. So P is equals to what will become 4V square by R. Power become 4 times. If I will increase the voltage, so power become 4 times, na? Now if
but
power become 4 times, then heat will also become 4 times.
sir, when
Hmm.
why not for heat we can use V into I into T, VIT.
See, basically, VIT, why we are not using? Because V and I both are the things that will change when you will increase the voltage.
When you increase the voltage by double, then what happens to VIT? To V.
See, R is the property of a conductor which never change. Even if you will increase the voltage or decrease the voltage, R will never change. First thing. Okay. V and I, they both will change. If I will increase the voltage, the current will increase or decrease, putting what you are putting thing. So where, see here, what we are doing while transmitting, we don't want to change the power. We don't want to change the power. So we want keeping the power same, like 20 watt and 20 watt. When we are increasing the current, we are getting that the current should be decreased. Okay, so putting the power formula same, when we are increasing the voltage, the current is less. Hence, if current is less, then here I square RT, the I is less, heat generated is less. Did you understand?
There are two different like
See,
two
there are
V
I
and
know there are two different things are
two
there.
different proportions between V and I.
V and I. So first is saying that if in a conductor, if resistance R is there, increasing the current, increasing the voltage, current will increase.
Yes,
That
V
is
is equal to
the
IR.
conductor. That is conductor.
Yes.
But if you want to put the power same, no loss of power should be there. Then if you will increase the voltage, the current will decrease.
Okay. So when resistance, so when resistance is the same, then when voltage increases, current also will increase.
Yeah, resistance should be same.
But here when power is same, then when voltage increases, current will decrease. That's what they say.
Yes, yes. Did you understand?
Oh.
So from this, what we can get? We can get that if you will increase the voltage of the bulb of 80 watt power of the 80 watt, then the current will be less, hence the brightness will decrease also.
Oh.
Did you understand, Edric? No.
Okay.
For
So,
example, 80 watt power is there. 80 watt power is there.
yeah.
Okay. Now, if you will increase, like voltage become high. So in that high voltage, the current will decrease. The fluctuation of current, okay, will not increase the brightness of the bulb.
And but what is the resistance is 80 ohm, 18 ohm. And then when the
Then if resistance is 80 ohm, then if power will increase, the current will also increase.
if voltage will increase, the current will also increase.
Yeah. Okay.
Ah. Hmm.
Now we'll talk about the household circuit. household circuit. Yeah. Agatha, read this.
Till the poles near our houses, electricity reaches through the distribution system. Two wires from the poles come to our houses. Among these, one wire is called as phase, while the other is called as neutral. In the phase wire, the voltage is 220 volt, while in the neutral, the voltage is 0, same as that of Earth. It is represented as N. Usually, the phase wire has a red colored insulation over it, while neutral wire has insulation of any color other than red or green. Inside the house, wiring is done in parallel mode, such that when one lights an appliance in a room, it doesn't affect the strength of current in another room. Household currents are shown in figure 17.18. We use another wire that has green colored insulation over it, which is called as earth wire or earth connecting wire. All the appliances are connected to the earth.
Okay. Mm, just give me a second. Okay. Just I'm asking last.
Sir,
Yeah.
so electricity comes to our neighborhood through the transmission system and comes to our houses through the distribution system. Is that the final conclusion?
Just give me a second. Just give me a second. I'm searching for something. Then I will give you answer. Just give me a second. Okay. Yeah. Tell me the answer. Yeah. What was you saying, Agatha?
Question. Okay.
What's the question? Yeah.
So electricity comes to our neighborhood through the transmission system and comes to our houses through the distribution system. Is that the final conclusion?
Yeah. That is the final conclusion. Now, basically, Edric, in the transmission, we are increasing the voltage. Okay.
Yes. Voltage will
We
increase.
want We want the power to be constant
But
while increasing the voltage.
resistance is also constant, no?
Resistance is also constant, but we want power to be constant, because if you will increase the power, then what will happen? Power, see, we know that power is basically V into T.
V into
Sorry,
I. V into I.
no, I'm thinking another formula. H is equals to power into time.
Yes.
Power into time. If you will increase the power, then heat will also increase.
Yes.
Hence, there's a loss of energy will be there, because heat is the loss of energy. While transmission, there is no need of heat energy. We want this power to be constant. We don't want power to increase, so that the
Sir,
heat will be constant. Just give me answer. Just give me the answers of this. Then I will ask. I will give the answers of everyone. We want power to be constant, so that heat will be constant. They won't be increasing the heat. First thing. Yes. Now the from this we got that power need to be constant. Now if power to be need to be constant, and if we are increasing the voltage, so in that case the current will automatically will decrease.
Yes. And but sir, but then time is also there. Time is also a factor.
Time no need, because time is basically the time is like, for example, from one place to second place, if the time is taking that, we can't change the time, we can't play with the time. But we what we can do, we can make the power constant with the various devices. So when we make the constant power, the heat will become constant. Okay. So for making the power constant, if we will increase the voltage, the current will decrease. That is the answer of that.
Okay, so power, we make the power constant. But if you want to make the resistance constant, then when voltage increases, current also increases.
Current also increases. Both different things are there.
But how? But if H is equals to I square R T and voltage is double, then we use the resistance.
Yeah. In that case, resistance will change.
I mean, resistance will be constant.
Resistance will be constant, but the current and voltage will change according to that.
Current and voltage will change. Both current and voltage will change. But the
Yeah.
resistance will be constant.
So now I give the example of bulb, 80-watt bulb. If voltage is high, the current will also become high, because in that we are not making the power constant. Even though 80 watt is there, but some in previous time, when voltage is very high, the bulb get fuse frequently.
Yes.
The bulb get fuse. Why? Because the voltage high let the increase of current high. Hence, the tungsten inside that wire, it becomes more heat and it gets fused. So in the bulb, we can't make the constant power P. If we can make the constant power P, then this principle will be applied. Okay, so in the bulb, when high voltage will come, then hence high current will flow. Hence, there it will damage the bulb.
So when high voltage means because resistance is constant, no. So high voltage means high current.
Mm. Hence, the high voltage, high current means the power will become double. If the power become double, then what will happen?
The heat will become double.
Heat will become double and the bulb will get fused. That is the answer. You got it?
Yes, sir.
Yeah, Agatha, now your doubt, please.
I just got confused. What is power? Power is the product of voltage and current, right?
Yeah, yes. So basically, power, we can say it like that. Power is the appliances having a voltage and taking a current. So if I will talk about geyser has lot of power, because in our house we are getting voltage. No, voltage is constant. So like power formula is V into I. This V is constant, 220 volt. Okay. Now if our appliances have 440-watt power, so in that case, what will be the I? How much current he is taking?
2 ampere.
Yes, 2 ampere into 2 ampere. Okay. Now, if a geyser, if it is take, for example, 110 watt, 1100 watt.
1100.
Okay. So in that case, how much how much current will be he is taking? He's
5
taking
ampere.
5 ampere current. So because geyser has high power, he's taking high current. Voltage is same. Did you understand, guys? Everyone understood?
Okay, so when there, okay, so the voltage is constant, then when current increases, power also increases.
Increases.
When
No,
current,
if voltage is constant and if power is there, if power increases, then current will also increase.
if current is constant and if voltage increases, then power also increases.
Increases, yes.
Okay, so like when it is like A is equal to B into C, one of them will be constant.
Yeah.
In multiplication formulas, no, like this and V is equal to I, no. If one of them is constant, the other two will change.
But the thing is, what was I'm trying to say? Like we know that H is equals to power into time.
Yes.
Yes. Now, for example, we'll take when 2 ampere current is there, when 2 voltage current is there, there is 2 ampere current is there. So the power is 4 watt.
Yes.
Yes.
Yes. Yes.
Now I increases the volt by 10 times. So it means that current will also increase by 10 times because we learn in the Ohm's law V is equals to IR.
No, sir. No,
How
sir.
much?
No. When 2 volt means it will become 20 volt. And then if the current is same, then the power will become 40 watt.
That is correct. That is correct. What I am trying to say, if voltage and nobody is constant. If nobody is constant, then what will happen? That is I'm saying. That is I'm saying. For example, in our house, if the voltage came high, first it was coming 2 volt, then it become 10 times, then become 20 volt. So
So what?
according to the Ohm's law, V is equals to IR. V will increase, then I will also increase. And if V is become 10 times, then I will also become 10 times. So the answer will be 400 watt. Means the power will increase exponentially and the heat will increase exponentially. Hence, the bulb will get destroyed. It will burn
No,
if nothing is constant.
I didn't understand why you put the Ohm's law in this.
See. I told you, na, if the voltage is increases in our house, then power is also increases.
Yeah.
Yes. So how power will increase? Because the current is also flowing in that increases. Because nothing is constant in that.
So in this one, nothing is constant. So that means the power will the
Increase
power will
exponentially.
increase by 100 times.
Yeah, exponentially. And exponentially means that the heat will generate exponentially and just a second, the appliance will burn. Just a second. Because it become 100 times.
So that means
Okay.
if H is equals to VIT and voltage is doubled, then that means V dash will become 2V and I dash will become 2I.
2I makes it
4 into
4,
I into T.
4 times the heat.
4 into H. Yeah.
Yes, that is the answer. Okay. So now, I know Agatha and David, this is like you don't know, able to understand it what we are talking about, but because it came from the previous chapter, it's okay. We will do it when we will have this chapter. Okay. Did you understand, Agatha and David?
Agatha already did that chapter. David didn't. So I want to teach David.
Huh? Thank you. Okay. Now, basically, we in our household we have 3 types of wire. First is red wire. The second one is black wire, and the third one is called as green wire. Okay, in our houses there are 3 types of wire: black wire, red wire, and green wire. So now, what does this mean? This red wire is also called as live wire. live wire.
Yes.
This black wire is called as
Neutral.
neutral wire.
So the green one is earthing, right?
Yeah.
Yes, the green one is called as earth wire. Now, everyone, please pay attention. Now, what is the use of live wire, earth wire, and the neutral wire? So, I told you electricity will only, uh, only will flow when the circuit is complete. If circuit is not complete, the electricity will not flow.
But sir,
Okay.
But sir, when electrons flow in one direction, electricity will flow in other direction.
That is correct. But what I told you, like for example, if I will draw the circuit for you guys, like this is a cell.
Battery.
Okay. The cell or battery. So from this, like this is positive terminal, this is negative terminal. The electrons will only flow when they will get the motivation to go to the positive terminal.
Free
For
electron.
example,
Free electron.
yeah. For example, if there is a break in the circuit, if there is break in the circuit like this, so the electron will not move. They will remain in the battery only because they don't have motivation to move toward positive terminal. Did you understand? So that is happened to our household also. Live wire have the flow of electron, but it only work when it is connected to the neutral wire, so that the flow of current should be there. Did you understand? Yes or no?
So
Okay.
flow of current will be there in both live and neutral wire.
When we plug the switch. So for example, in our household, we have these types of switches. Indian have this type of switches. 1, 2, 3, 4, 5, 6, like this.
Yeah.
Yes.
Yeah.
So in that one, like this will have live wire, this will have live wire, and this will have neutral wire, and this will have neutral wire.
And the
Okay.
top one will
Now-
have earth wire.
And this one will have earth wire.
Yeah.
So for example, if I will put my charger in it, if I will put a charger in it, so I will put one in this and one in this. Then only the charger will work. If I will put one in this and another in this, then both are live wire. The charger will not work, not at all work. If I will put in this
Sir,
both black wire, the charger will not work. Yes.
what are the charges in the red wire and the black wire? I mean the live wire and the neutral wire?
Then the charger will work, and normally it is working
No,
like
no, no,
that
no,
only.
no. I'm saying what is the charge in the live wire? Positive or negative?
In the live wire,
Yeah, charge.
the charge. I mean, see, every time from the black wire, the electrons move towards the positive wire. That is the main concept. Okay, electrons move from negative terminal to the positive terminal. So electricity always work against it. Means if electron is going towards east to west, electricity is going from west to east. So if electrons are moving from negative terminal to the positive terminal, so the electricity will move from positive terminal to the negative terminal. So from that we can conclude that if I will connect a charger with one red wire and then one black wire like this, if I will placed it, the electron will move from the negative terminal and go toward the positive terminal, means red wire. But the electricity will move from red wire to the black wire like that.
So red has positive charge, then black has negative charge, and green has neutral charge.
I told you, yeah, we can say that it's positive, but it is not correct. Why? Because positive charge never moves. Always electron moves. I told you before also. Electrons are the responsible for the movement, and because of that only the electricity is formed. So we can conclude it like that. The electrons move from black wire to the red wire, and in that opposite direction, the electricity move from red wire to the black wire. We can say like that, but we can't say that red is positive and black is negative. We can't say that. Okay.
Protons don't
Okay.
move because
Protons,
protons don't move because they have a high mass. But electrons,
no, even they have high mass and they are inside the nucleus. Electrons are outside the shell, so they can easily move.
like that I said in periodic classification of elements, no, in this one, in the beginning, I mean in the first group, no, The electrons are like spread way out, but in the group,
Yeah,
electrons is spread like so very close to the nucleus.
yeah. Did you understand? Everyone understood what I'm trying to say, David? Are you there? Did you understand, beta?
Yes.
Yes, sir.
Okay. Now one more thing. So basically, the red wire and the black wire is there. So do you know tester? Do you know tester? What is
Yes, sir,
tester?
yes. So it's like a
Tester,
screwdriver which has a small bulb in it,
yeah.
and then you
So
put in the
yeah,
plug point.
perfect. So if I will put tester into this in the black wire, will the bulb will glow? Not at all, because black doesn't have any current in it. Okay.
Red.
If you will put in the red, the current will be there, hence the bulb will glow. Did you understand? Hence the bulb will glow. Basically, what happened? Do you know what happened? If you will know how to use the tester, then only the bulb will glow. If you will put your finger on the tip of the tester, then the bulb will glow. If you will just hold it like this, the bulb will never glow. So basically, what happened? Basically, what happened that the electricity coming from the red wire, and we are working as a negative terminal which is going towards the earth, so the circuit will flow. See what happens. The positive, the red wire, basically electricity is flowing. The electricity, when we touch that the tip of the tester, then we are making electric circuit from the positive terminal. This goes to the my hand to the earth, and the circuit is formed, and the bulb will glow. But if you will not touch the tip of the tester, then the bulb will not glow, not at all glow, because the circuit is not formed. Yes, David. Yes, Joshua.
So won't you get a shock if you do that?
Because the resistance is too high of the tester, the resistance is too high. Too high means the current will flow very less, so you will not get any shock.
And sir,
Uh,
oh, I forgot. But sir, like how to like prevent the contact between live wire and neutral wire?
because there's an insulation in that. Insulation. The red wire has insulation, and the live wire has insulation, and neutral wire has insulation, so they won't attach to each other, and they don't give any sparkling.
So all three wires have insulations. All three.
Yeah, all three wire have insulation. Plastic insulation is over there.
Oh,
Did you
that's why we don't get like a spark or something with like fire or something.
Sir,
Yes, please.
the wire itself color is in red, blue, or green. It's the insulation they are on, right?
Yeah.
Insulation are made up of the color of that wire only. If we are using live wire, so that will have only red insulation color.
Okay, so
They
live
do
wire is red and neutral wire is black and earth wire is green.
Which
Green.
means we can switch the insulation and make like the neutral wire can have red and the live wire can have black.
Yeah, we can, no problem in that. But if, like for example, if you are an electrician and if you will do like that, and the if something happens, if something problem happens, then the new electrician will come. He has universal that red is this and this, and then he will switch it, and then the house will have a lunch with Jesus. So basically, that will happen. So this is universal. That's why you have to keep red as live, and then black is neutral, and the green is earth, like that. Okay, now one more thing. What is the use of green wire? So now, basically, fridge. You will check the fridge has 3-pin socket like this. Two,
Yeah.
and the one is up. Geyser has 3-pin switch. Oven, microwave oven, if you have microwave oven or heater oven, 3 switch. So the big appliances of like these, charger doesn't have 3-pin switch. It has only 2-pin switch. Okay. Laptop charger has 3-pin switch. So basically, the
Most of them have 3-pin switches only.
cooler also have 3-pin switches. Why? Because these appliances, sometimes what happened, because of the circuit inside that, in the cover, like fridge cover or the geyser cover, they have current on it. Means if you will touch the surface of the fridge, you will get a shock. So to reduce that shock, even though it is not too high, but it is, yeah, you get little shock. So you go, oh ma, I ma, like that you will do. So to reduce that, the green wire is attached to the, like, the third pin, the all the circuit. It's connect to that, so that the excess current can pass through this green wire, go to the earth.
So green wire will go to the earth.
Yeah, green wire, like every house, if you have good earthing, so in your house, the green wire, all the houses having the socket green wire will come attached to the copper plate, put inside the earth, so that the you will not say any uima aima when you touch the fridge. Did you
Okay.
understand?
So most of the chargers, I mean, the sockets, they have 3 pins.
Yeah, 3 pins. But if sometimes, like in our Rajasthan are very jugadu. We don't if 3 pin socket we are not able to find, we leave the green wire and we put the red and black wire into it. Okay, so then we will understand that the jugadu is not good when the appliances will burn, and then we will have problem with that.
Okay. So like even if like you are lazy, to like put the green wire, your house might have a lunch with Jesus.
Yeah, not even the house, the appliances. And if, like, I remember one case, in that case the person did their jugadu work, like we have desert cooler. The cooler give good airflow, okay, and it has 3 pin socket. But that person did that jugadu work. He only took the red wire and the black wire, and he
Yes.
put it in the socket, and he was using it. Now one kid, he's playing and he's using all this thing, and he touched the cooler. He stick to that cooler only. He's not able to get out of that cooler. He got that much shock that he's not able to put him out of it. Okay, so sometimes it happens also. Okay, even in AC, if you will stick it, you will get a chance. Okay, to get it out of it. But if you are just give hug to the AC current, then sometimes you will not able to get out of the AC current. Did you understand?
Sir,
Yeah,
does AC use AC current?
yeah. AC use only AC current. Okay, did you understand, guys? David, Agatha.
Yes, sir.
Okay. So yeah, in our house there is parallel combinations are there. What combinations are there? Parallel combinations. So for example, if David is working something in tube light, now what happened? That tube light, like he's working some tube light, and because of that some spark happened, and the tube light get bombed. Not bombed. Basically, it get fused. Like stop sound came. Now, because of that, will the current in the kitchen will stop? No. Like he's working in drawing room, in guest room, but the kitchen will not work. So what will happen? Um uh, the fan will not stop working. The fan will not, like if you will like the tube light get destroyed because of that. So because of that, the fan will not stop work. Why? Because in our house, all the appliances are connected in parallel. So for example, what will happen? Listen. So for example, David is working in the tube light. So for example, this is tube light. Okay, and this is fan. Now, don't laugh on my drawing, please. Bear this with this. So, what will happen? That if tube light is not working and tube light get destroyed, still the fan will work because it's a parallel combination. If it is a series combination like this, then what will happen? If tube light is not working, the fan will also not work
Because the circuit will break.
because circuit will break. Okay, so to get rid of this, we are using parallel combination in our household. First thing. Second thing, the series have more resistance. We learn that R1 plus R2 it will become. So it becomes 7 ohm. And in this case, it will become 1 upon R1, 1 upon R2, which is less than 1 ohm. So if resistance is less, the current will be more. Hence, there is a good amount of current will be there if you will use parallel combination.
So basically, like the fan acts as a resistor.
Yeah,
Oh,
fan has power is equals to V square by R, and R is resistance.
and R is also constant because resistance is also constant.
Yes.
The
Okay.
property of an appliance, it's actually.
Yeah. Now we will read this. So I request Ira to please read this.
Precautions to be taken while using electrical energy. If electricity is used in a careful and safe manner, it is the largest and most convenient form of energy. If one uses it carelessly, it will become lethal. After working with electricity, one must ensure whether it is AC or DC current. DC at the same voltage of AC is more dangerous. Do
So
not
if the line will come, why the DC of the same voltage is more dangerous? So what will you write? David, what will you write? If the question will come like this, why the DC of the same voltage of AC is more dangerous? If the
Yeah,
question like
it's because there are no intervals in between. It doesn't stop in between like AC.
Like
yeah,
the current will never ever become zero in DC. It'll just go up, then touch above zero, but it'll never touch zero.
it will not change
It's
the direction.
continuous.
It will continuously. So this is the question you guys have to do in your homework today. Okay. So write this question and then write give reason. So you have to elaborate it in minimum 4 to 5 lines. This is your task. You know the answer, guys. So you have to elaborate it into 4 to 5 lines.
Sir,
4 to
just
5.
one thing.
Yes.
We do the homework and then send it to you without knowing if it's right. And do you even check our homework?
See, sometimes I check it, sometimes I forget it because I have my offline classes also. So yesterday I was busy. But yeah, if I find any problem, na, so I used to tell you directly that it is not correct. But I will check like 1, 2, 3, 4, 5, 6 continuously. Some day if I miss, so I will check it another day. But I will check. I check regularly. There is no problem in that. Okay. Not too deeply like calculations and all, but yeah, I check that steps are there or not. Calculation you can check it, like you can check with another copy also if calculation mistakes are there. So not too deeply, but yeah, I check that the homework is there or not. Okay. Now because of today is these times are Christmas time, so we are busy with that also, so bear this. Okay. So now do not touch electricity supply wire with the bare hands, but there is a catch in it. Okay, so basically, what happened in our church? I was the winter done. Now summer came. So summer we have to put the fan back into the wall. So I was become a Shaktiman in that. Not Shaktiman. Who's the electricity man?
Sir,
Yeah,
why do you remove the fan during the summer?
in the winter
I mean in the winter? Oh, because you don't need it?
because we don't need it because winter is too good that we don't need any fan in that.
So
So
But
why
Agatha,
can't you just leave the fan over there and not turn it on? Why do you have to
um,
remove it?
because there is too much dust is there, no? It's all about desert. So the fan will get dusty, like dirty, and then so instead of that, we clean them, put it into the safe box, and then when summer will come, we'll directly plug it like that. So there's like wall fan. It's not a ceiling fan. Ceiling fan is always there, but the wall fan is there. Okay. So I was become a superhero. So because I know the science, so I was telling to my juniors one, see, I can touch the wire with the bare hand. So what was I'm doing? What was I'm doing? I will tell you that thing. I was having a sleeper, not sleeper, the shoes, proper shoes. And when I'm plugging the fan into it. So I am touching the red of the main wire and the red of the fan wire, and I am plugging it like this. Okay. While doing this, I am not touching the black one, because if I will touch the black one, then I will somewhere in the hospital.
Spark.
So what I
Spark
was
will
doing?
come.
Yeah, what was I doing? I was touching the red to red. While that, I'm not touching the black one. And if I will touch the black to black, I will not touch the red one. Okay.
But
So
black to black, there is no voltage. So only red to red you can the current will
yeah. So while doing this, everyone was clapping with me, because they are saying that, oh, you are an electricity man. So it's not electricity man. I know the sign. That's why I was becoming a hero in their eyes. Okay. So yeah, but you guys do not do it, because electricity has no friend. Okay, if you did some mistake, then electricity will give you a good tight hug. Okay, and because of that, you will get a good spikes in your hair. Okay, so please read this. Who was reading?
Ira.
Ira, please.
Do not touch electricity supply wires with your bare hands. One may even die due to shock from current. AC flings a person away while one gets stuck to a DC source. The main switch should be switched off in case of any accident. One must separate a person who has received a current shock with the help of a safe non-conductor. Example, rubber, stick, shoes, gloves. Never touch such a person directly.
So I'll show you
So-
one scene. Yeah.
Even if you're wearing shoes and someone is getting shocked, if you try and pull them out, will you get?
You may be, or you may not be. Basically, it depends on the environment also, the humidity also. If shoes are wet, okay, so it is okay to use the always stick. Even the stick should be not wet; it should be dry. Okay. Just give me a second. I'll show you one video. Where is that scene? Yeah. I'll show you one video, even though it's not allowed, but the mistake what they did, we'll just see that. Okay, so there's a movie scene. Okay. We'll check this.
What is that? The metal rod.
Yeah.
One got shocked and the others tried to say that wasn't
Metal rod.
Metal rod, so don't use that. Okay, so use only stock. Okay, yeah, we'll go to it.
कितना दौड़ाएंगे
अरे माची सर क्या
So here basically
everybody getting shocked. Even if, you
Yeah,
touch,
don't.
even if you touch with a wood also, you'll get a shock.
Yeah, you're putting like wooden suit, and if you're touching with your bare hand, then you will make a chain like that. Okay, so this is for fun. Okay.
Yo, that was like I I'm
Okay.
scared to touch anything now.
Okay. So you guys learn the precaution. Okay, just we'll go quickly with that because today I have to complete this chapter. Okay. So never use extinguisher fire during the electric spark. So yeah, don't if something like some fire is there which is related to electricity, don't go and just put the water into it. Then you will become like that only because the water is a good conductor of electricity. The fourth one is switch off the thing. Use rubber gloves, shoes, all these things. Then in house wire, use ISI mark switch. ISI mark switch means there is a Indian standard something like is there. So use that only switch. Don't use another switch. There is a MCB. MCB is called as miniature circuit breaker. So if something spark or something shock happens, so the MCB automatically will go down, and because of that, the electricity will not go through it, so that you can be safe. Okay, all switch should be switch off when the large main switch current will flow to the current of emergency. So if some fire is happen in the building, okay, so instead of going to somewhere else, go to the main meter, switch off the main switch so that all the electricity will go off, and then you will put the water into it for that. Okay, so this is what we learn. Okay. Now, basically, what is this? This is something are there that may cause the accident during the electricity. First is leakage of current. Now, what is leakage of current? So, often due to continuous flow of electric current, insulation wire gets affected and scrapped off. So, somewhere else, for example, if the insulation of that wire gets scrapped off, and if another like red and black wire, they both come and they both touch it. So because of that, spark generated and spark generated fire happen. Did you understand, guys? The second is short circuit. Short circuit is happens when neutral and main wire came contact to each other. Sudden huge spark, short circuit. Overload. Now, what is overload? So, for example, we Indians do one switch. We put all the appliances. We put fridge also. We put oven also. We put mixie also. One switch. That is called as overloading. That should not be done. Okay. So, if the wire has only capacity to get 5 ampere current, but you are putting fridge, you are putting oven, you are putting microwave oven, mixie, and all this thing in a one switch and using all at a one same time, then what will happen? That the excess current will draw from that, the wire will get melt, the fire will happen. Okay, yes or no? Now first is electric fuse. Now what is electric fuse? So for example, so if the fuse is like this and the fuse has a wire like this, okay, so now the fuse is set. Okay, the fuse is made up of alloy. Alloy is the mixture of two metals in the molten state. So, for example, if only 10 ampere current can go through it, okay, the fuse is set according to that. If, like for example, in a house you are using 6 geyser at the same time, the 6 geyser will draw maximum power, maximum current. Maximum current means the wire will get fire. So to get rid of that, the fuse is set into some specific current value. If it is goes above that, the fuse will melt. The fuse wire will melt like this. Hence, the current will not go to the wire. So our house is safe. This is the use of fuse. Did you understand, guys? David, Ira, okay. So the second one is miniature circuit. Now we are not using fuse, we are using MCB. Okay, the MCB directly go to the down and the house is safe. Yes, somebody saying something. Hi. Shut up, shut up.
Zoe,
Okay.
Is that Zoe?
Yeah, she was fine. What happened? Sudha.
Show the Zoe. Show the Zoe.
I don't
Yes.
think he can show.
Zoe is like how many years? 1 year or a few months only.
In
Is
April,
he?
she. Yeah.
Is he Sir's son?
No. She's my bhanji. Yeah, niece, nephew, whatever.
So who's Radha ma'am then?
Radha ma'am is my sister. Okay. Come.
Then,
Yeah.
then there was Rebecca ma'am and Sakshi ma'am.
Rebecca ma'am is from Ajmer, and Sakshi ma'am is from our church only. She is there. Go and give hi to them.
Hi, good morning. Good morning, Zoe. Pin. I'm pinning. Wait.
Oh, edit down. Oh, you're pinning her. Zoe.
I'm pin.
Okay, so earthing of electric appliances, I told you the earthing is necessary so that all the excess current of the devices go directly to the earth. Yes or no? So we did till here. Any problem? You guys can ask me. Now the chapter is also complete. You guys can read it at home. Okay, we'll. It's very easy. I taught you everything. Yes, Dashram, please.
So I've in the thing about where the electricity goes to the house and face wire is 220 volts. Is that set standard for every house or is it just in the book?
No, it's standard for every houses. You can go and you can check. For example, do you use waffle maker or even your charger? If you have charger, you can check the charger input and output. If it is written, you can check that it is the range is set of 220 volt to 240 volt. So above that, the appliance will burn. So it is set 220 to 240. Okay.
Is there any appliance with like 220 to 260?
220 to 260 is there, but basically all they have specific range which is 220 to 240. Any problem, guys? David has problem. Miracle.
Wait. Zoe is a boy or a girl?
Girl. She's girl. Sleep, guys. Sleep, girl. Choti basi, sleep. Okay. So no problem, guys.
No, sir.
Yes, sir.
Chapter now, right?
So chapter is completed. Now we will go to the next chapter tomorrow. What chapter, Ira? In biology.
Biology, there's life processes 2 and then life processes 3 also there. One we finished, like
22 we finished. 23 we need to do next.
yeah, 23 and 24.
23.
Okay, so we'll go to the 23, I believe. Let me check. Tomorrow we'll go to the chapter number 23. Hey, this is not 23.
Trigonometric ratios of such language. 23. 23. Yes, still holding Zoe. This one, control and coordination.
Coordination. Okay, guys?
Yes.
Tomorrow.